last example that we started doing, I wrote the problem down wrong to begin with. So the denominator was actually the cosine of alpha times the cosine of beta. And so then when we did the thing to the top that we did at the bottom is just the cosine of alpha times the cosine of beta. Therefore, we were finished with the problem. And we're done. Okay. Point 4. All right. We're going to find the exact value again. And find the exact value of the sine of 5 pi over 12. And it gives us a hint in the book, and it tells us that 5 pi over 12 is equal to pi over 6 plus pi over 4. On the homework, most of the time you're going to have to figure out what the two things that you've got to use to add up to that. Okay, so they gave us the hint that we know this is true. So what we're going to do is we're going to take the sine of 6 pi over 6 plus pi over 4. Now on the sine formula, then we keep the operation the same, but what happens is I use the sine and the cosine in both parts of it. So I've got the sine of the first one times the cosine of the second one plus the sine of the second times the cosine of the first. Yeah, if you need it in degrees, then pi over 6 is 30, right? And pi over 4 is 45. So you've all got these memorized. I know you do. The sine of 30 is 1/2. And the cosine of 45 degrees is the square root of 2 over 2. The sine is also the square root of 2 over 2. And the cosine of 30 degrees is the square root of 3 over 2. We just did that a little bit ago. So if I multiply these together, I get the square root of 2 over 4. And here I get the square root of 6 over 4, because remember, if I'm multiplying things, I can multiply the stuff under the radicals together. And so in the back of the book and on the test, the answer choices are going to look like this, where they put it together as just one fraction. They're going to write it as the square root of 2 plus the square root of 6 over the square root of 4. Huh? Didn't I say over 4? I'm sorry. Thank you. Not the square root of 4, just 4. Okay? Checkpoint 5. They tell us that we're going to let the sine of alpha be 4 over 5. And the sine of beta be equal to 1/2. Now this one's in quadrant 2. And this one's in quadrant 1. And they want us to find the exact value of, there's several of them there. A asks us to find the cosine of alpha. Because everything we've done so far, all the formulas require the sine and the cosine, right, of the same angle. So if I know that the sine of alpha is 4 over 5, how do I find the cosine of alpha if it's in quadrant 2? Number 1, I know it's negative. All smart trig classes, I know it's a negative, right? Because I'm in quadrant 2. And remember that sine is y over the radius r. So I need to find x, and I know that x squared plus y squared is equal to r squared. So x is 3, because that's a Pythagorean triple. I told you to memorize that, 3, 4, 5, right? So I get the cosine is negative 3 over 5, cosine of alpha. And then in part B, what do you expect they want us to find? Sine, I'll be all right, the cosine of beta. If I'm in quadrant 1, I definitely know cosine is what? Positive. This one's not as easy, so I'm going to have to go ahead and draw my little right triangle here. So if here's beta's down in this corner, then that's the opposite over the hypotenuse, right? Square root of 3. Everybody understand how I got that, right? Square root of 2 squared minus 1 squared. All right, so cosine of beta is the square root of 3 over 2. So part C wants us to find the cosine of alpha plus beta. So using the formula, that's the cosine of alpha times the cosine of beta minus the sine of alpha times the sine of beta. And we just found all those values, so we can just plug those in now. Cosine of alpha we said was negative 3 over 5. Cosine of beta we said was the square root of 3 over 2. Minus the sine of alpha was 4 over 5, and the sine of beta was 1/2. So I've got a negative 3 times the square root of 3 over 10 minus 4 over 10. So when I put that together, negative 3 times the square root of 3 minus 4 over 10. That's your answer. Part D asks you to do the same thing with the sine of alpha plus beta. I'm going to leave you to do that for yourself. Checkpoint 6 talks about you putting your, setting a graphing window, a viewing window on your graphing calculator and putting an equation into the calculator and y equals. And then looking to see by the graphs if those two pieces are identical. We're not going to do that one either. We're going to go on over to checkpoint 7 and finish up. Checkpoint 7 says to verify the identity, the tangent of x plus pi is equal to the tangent of x. Now we talked about that, right? What's the period of tangent? 1 pi. So what's going to happen at every pi? Going to get the same tangent value back, right? Now we know this. Now let's prove it. So the formula for the tangent of the sum is the tangent of alpha, so it's the tangent of x, plus the tangent of beta, the tangent of pi, over 1 minus the tangent of x times the tangent of pi. Now, tangent of x I can't do anything with, right? That's just a variable. But I do know what the tangent of pi is. What's the tangent at the 90 degrees? I mean at the 180. 0. Right? Do you need me to show you? You got it? All right. So 1 minus the tangent of x times 0. So the tangent of x plus 0 is just the tangent of x. And this is 1 minus 0, which is just 1. So tangent of x is equal to the tangent of x. And we're done with that verification. So on your homework assignment, you're just going to be doing a combination of these types of problems. There's some verifying and there's some where you actually find exact values. The problem set that I gave you to do is on page 604, 15 through 63, multiples of 3.